Well, we hope you're enjoying your reInvent so far. My name is Justin Perl.
And I'm Vladimir Burilov.
And thank you for joining us today. By show of hands, how many of you are working on apps where your users need to sign in and sign up? So 95+%, OK. And of those apps, how many of your users do you need to have different permissions in your apps for different users? OK, so the majority of you as well. Well, today we're here to share best practices and tips on how you can accomplish these goals in a secure and serverless way. This talk is modeled after a talk from reInvent 2016, but many services and features have changed since then. So if some of this content looks familiar to you, realize there's a lot of new stuff we'll be demoing and talking about today as well. To make this real, what we've done is to walk from a perspective of building an app, in this case a hybrid mobile app, using JavaScript SDKs behind the scenes, from start to finish, starting with sign up and other concerns as we go. And this app and all the demos you see today are available for use now on GitHub at AWS Labs. And we'll have this again for any photos at the end. But just know, do try this at home. All of the source code of all that you see is available for your use to accelerate your development under the Apache 2 license. Just so you know, SpaceFinder is a conference room finder application. So a simple app to find a conference room, book a conference room, etc. Though you'll see how the identity concern plays throughout. And to talk you through more about how we approach identity, I'll turn it to Vladimir.
So imagine you're sitting at your desk, drinking a cup of coffee, waiting for the work week to start, and an email pops up. You have to create a mobile application that allows users to sign up and sign in, upload their profile image, and search and book conference rooms. Well, what do you do? Where do you start? Well, since identities or managing identities is an integral part to most of these components, you should start there. Well, you want the user to sign up and sign in. How do you do that? You might roll up a database and store the credentials. How do you store the credentials? Maybe in clear text format. Now, how many of you know of a system that does this right now in production? Just one. I'm glad it's just one. It's a definite anti-pattern for obvious reasons. One of them is you can have a rogue employee go and scan the whole database, and you have a huge problem on your hands. Well, you can hash passwords. It used to be really common just to hash passwords and save those hash passwords in the database. But with rainbow tables and with dictionary attacks, you're not safe anymore. What's a better approach? A better approach is to salt hash those passwords. And that's actually what's being used quite often these days. Now, what if you did not want to transfer the password over the wire, even in a salted hash format? What if you didn't even want to save the password in the database? What can you do? Well, you can use Secure Remote Password Protocol, which was developed at Stanford. And what that is, it allows you to create a verifier code from the password and transfer that and save that in the backend. Well, now that we've settled on how you're going to actually take care of the passwords, what about the other requirements, such as multi-factor authentication? How about enforcing password policies or encrypting data on the backend? And what about other authentication flows, such as, let's say, including CAPTCHA, for example? And what if all of a sudden this application becomes so popular that you want to scale it out to hundreds of millions of users? On top of that, what about the user flows? On top of sign up and sign in, you want to be able to have the functionality to reset a password or change a password, obviously sign out. Well, thankfully we have a service for you, and it's called Amazon Cognito, specifically Amazon Cognito User Pools, which is our managed user directory. And Justin will go over the actual process of sign up and sign in using Amazon Cognito.
Thanks, Vladimir. So to walk you through how you can use Cognito User Pools, let's take a look through the common flows with our SDK. So it all starts, of course, with sending the user's information for registration. And then you can optionally set up the requirement to validate either a customer's email or their phone number via SMS, as a validation built into the service. And then from there, once they've actually taken the code that they got back via email or SMS and confirmed their registration, only then do you have a successful confirmed user which can actually authenticate. So once the user goes to authenticate, this is done via Secure Remote Password, or SRP, as Vladimir said. When you authenticate and send correct credentials, Cognito User Pools returns to you a set of JWT tokens, or JSON Web Tokens. We'll talk more about those if you're not familiar. But what if you have other needs? Beyond this basic flow, if you need to hook in and customize this authentication and sign-up experience? Well, you can heavily customize this flow. So you could first authenticate just like before, but say you need maybe a CAPTCHA, or you want to do multi-factor auth using a very particular multi-factor auth option. Cognito has it out of the box. Say you need something else. Well, you can define a custom challenge, which is a Lambda trigger that you can hook into the workflow. That could generate that challenge for your users and send the challenge back. And then your users can respond to the challenge in your own app, sending the challenge response back with yet another Lambda function to verify the challenge response. Now, once they pass the challenges, then of course you get the JWT tokens back just as before. But this is just one example of how you could customize your user experience. To show you a more comprehensive list, here's a full view of a lot of the Lambda triggers that you can hook in from the sign-up moment all the way through your post-authentication logic to customize your flows. Now, I know I mentioned you're getting back JWT tokens. So for those that aren't familiar, let's take a look at what a JWT token is. So a JWT token has a header, a payload, and a signature. And all three together as a base 64 blob of text, encoded blob of text, make up a JWT token. So this is an example of an identity token. So if you look at the payload, all of the user's attributes that the app client has access to read are encoded in this token. So my email, my first name, my last name, unique ID, etc. The header indicates the key used to sign the token and the signing algorithm, and the signature is there to validate that this token is in fact from the source that you expect it to be from. In this case, a particular user pool within Amazon Cognito. Now, with this token, there are three types of tokens you get from Amazon Cognito: an access token, an identity token, and a refresh token. The access token is there to provide access or programmatic sort of API interactions for the user. The identity token, which you're seeing here, can be used for downstream sort of pseudo-authentication, or used for downstream sort of reading of the claims of the user and being able to dynamically change the experience of the user in your application just reading the token. And the final one is something called the refresh token. And the reason this exists is the access token and identity token from Cognito are only good for 1 hour when they're issued. But a refresh token can be customized per application to be valid for as long as 30 days. And you can use a refresh token to get a new access and identity token. And all of that is possible if you leave a long refresh token without the user needing to authenticate again. So now we have a way, building up our SpaceFinder application, that a user can sign in and sign up. But what if they need to access AWS resources? So in our case, each user has their own profile. They want to have a profile picture. We want to take advantage of Amazon S3 for that. Well, to give them secure, fine-grained access to Amazon S3, we need something else. And there's another feature of Amazon Cognito called Cognito Federated Identities. And what this service does is it allows you to exchange tokens from user pools or another bearer token-based provider for AWS native credentials in the form of an identity and access management or IAM role. So these credentials are an access key, secret access key, and a session token. Let's take a look at how that works behind the scenes. So first you would authenticate with Cognito user pools. You get back your set of JWT tokens, just as before. But this time you would make a subsequent call to go ahead and pass the identity token to Cognito Federated Identities, which would return you an identity ID. Now with the identity ID and the identity token, you can then call to make a get credentials request, which behind the scenes, Cognito goes to the Security Token Service, or STS service, which is AWS's token vending machine, effectively. So all AWS access keys you ever see come from STS. And this generates the particular credentials for that role, and ultimately Cognito returns them back to you in the form of an IAM role. So that's the access key, secret access key, session token. Once you have those credentials, you can then go ahead and use any AWS SDK for any language you normally use to interact with AWS resources. So in this case, S3, but that could be DynamoDB, API Gateway, or some other service. But a lot of you said you have different users that need different permissions in your application. So how can you solve that challenge? Well, prior to December of 2016, Cognito Federated Identities only had an authenticated user role and an unauthenticated user role. But in our case, we want to have different users with different permissions. Now there are two additional options available for you for fine-grained access and authorization called choose role from rule and choose role from token. The first one, choose role from rule, in your user pool, you can define different attributes. In this case, we have a user pool with a department attribute. And you can make a set of rules based on these attributes. So in this case, we're parsing the department. And if someone is a member of, say, the engineering department, we give them the engineer's role. But you can define one or more rules that are processed in sequential order. And the first matching rule would be the effective role that the user gets. Now, if you have a user that comes along that doesn't match any of your rules that you define, then you can decide, do you give them the standard authenticated user role, or do you just deny their access altogether with federated identities? So that's one option. The other option available to you is something called choose role from token. And this is particular for use with Cognito user pools, where we have a new feature also launched last year called Cognito groups. You're able to define different groups for different users. A user can be in more than one group. So with each group, you can specify an IAM role for each group and a precedence value. And what that means is if, in this case, we have an example user here who's both an admin and in the finance department, but because the admin group has a precedence of 0, which is lower than the finance precedence of 2, this user would get the IAM role of the admin group. You can only have one IAM role at a time. So this is another option for you that's all out of the box. And all of the logic of deciding which role and issuing the appropriate tokens for that role, all of that's done by Cognito for you. So you make the same calls either way, and it's just dynamic. So to show this to you in practice, I'll turn it over to Vladimir, show you the app.
So there's a lot of moving components here. And in order to showcase most of them, we created the application and we created a lot of, we created a lot of logs. So here you will see a lot of those logs printed out as I interact with the application. So let's start by signing up. Let me enter the username, password. Okay, so what's going to happen now is I'm going to click sign up, and Cognito will sign me up, but I'm not confirmed yet. What's going to happen is Cognito will send a confirmation email to my email address with a code. So let's take a look. All right, so I got the code. Now I have to confirm my registration. All right. I'm confirmed. All right, now let's log in. Sign in. Type the username. The password is the same. All right, so as you can see, there's a lot of information printed out here. So things to note, the 3 JWT tokens that I mentioned before are printed out here, and the access credentials that Amazon Cognito Federated Identities has vended. So let's take a look at one of these JWT tokens, specifically the ID token, and let's decipher it. All right, so you can see the header, the payload, and the payload contains all the information that I entered. So you can use this JWT token in your downstream services for further customization and further authorization. And you have the signature. The signature you will use in your downstream services to make sure that this is a valid JWT token. You want to make sure that Cognito was the one who created it. All right. Now, let's take a look at the one thing that I wanted to show you, one additional thing, is uploading an image first. So let's go here, select an image. We have a couple of pictures here. All right. So we've uploaded an image just now. And what happened is the image went directly from this mobile device to S3. It did not go through a server. It did not need a proxy. It went directly to S3. So that was possible using IAM roles. And it's stored in a S3 bucket that only this user has access to, meaning the S3 bucket's prefix. Only this user has access to the image that was just uploaded. No other user can access it. All right, so let's take a look at the Cognito console. All right, so first, let's start with user pools. The first thing that you see is the pool ID. That's the unique ID that you will be referencing throughout your application. Now, you have a dashboard of everything that's configured, and as an example, estimated number of users that's in this Cognito user pool. Now, the second thing I want to show you are the actual users and groups. So these are the users that have logged in or registered with this Cognito user pool. And these are the groups that Justin mentioned. And let's take a look at one of them. So as you can see, this group is associated with a particular IAM role. So what that means is if I place a user into this group, that user, when authenticated, will have that role as part of that token. All right, the attributes, Cognito comes with default attributes, and you can also create custom attributes. So think of custom attributes as what's your favorite color, or has the user paid, as an example. And it's important due to the fact that in order to actually talk to Cognito, you need an app ID as well. So here we have configured two app IDs. One is the admin ID, and the other one is the ID that's being used by this Cognito application, right? So as a client. So the client one is configured to use SRP, and one very important thing to note is we're actually telling what attributes this client has access to in regards to reading and in regards to writing. So imagine the following situation. You have the client accessing and writing, let's say, the color, or my favorite color, for example, right? But you don't want the client to have access to an attribute that specifies whether the client has paid for a subscription or for a conference room, for example. You don't want the actual client to modify this value. You want an admin application to modify this value. And this is where that's set up. We've turned off SRP here, and the admin application has access to all of the attributes, including these three. All right. Now, the next thing to note are the triggers. So this is a way for you to customize the authentication and the authorization flows. And Justin went over this a little bit more. These are just simple Lambda functions that you can use, and we have plenty of reference Lambda functions for this. You can also turn on analytics, which basically turns on pinpoint. All right, so let's take a look at the federated identities. So just to remind you, Cognito user pools is your user directory. It stores the users. It allows for an easy way to create the sign up and sign in functionality. Cognito federated identities is what allows those users who have logged in with Cognito user pools to get AWS credentials. So you exchange JWT tokens for AWS credentials. And that's the way that those users, inadvertently through the application, are able to access the AWS services, such as S3, API Gateway, and anything else. So let's take a look at the pool. Okay. So what you see here is a list of available providers or type of providers that you can integrate within this within federated identities. What that means is you can use Cognito to allow your users to sign up and sign in, but you can also use Facebook or Twitter or OpenID provider or any SAML provider. And if you have that all packaged in your UI, and let's say the same user logs in with Cognito, and then later that same user decides to log in with Facebook, they have the same federated identity. So you can identify that user within the login process, okay? Now, as you can see here, the setup is quite simple. You specify the user pool ID, you specify the app client ID, and you specify the fine-grained controls here and here. And just to show you quickly, Facebook, Google, Twitter. Okay. All right, so you've allowed your users to sign up and sign in. You've used federated identities to allow your users to upload their profile image. So now you're ready for the business logic. And for the business logic, you can use API Gateway, Lambda, and DynamoDB. And Justin will go over the details of how that's implemented and set up.
Thanks, Vladimir. So with our SpaceFinder application, we'd like to have a fully serverless application, right? So the serverless API pattern that's very popular and common is API Gateway, AWS Lambda, and Amazon DynamoDB. And so we have that in SpaceFinder. The nice thing about API Gateway being in this mix is you're able to offload all of the authorization and authentication decisions for your actual business layer to API Gateway. And the way we can do that is 3 different types of authorization options. First, I want to show you, just to set the context, this is SpaceFinder's API. It's a simple RESTful API. But within this API, we do have certain operations that are admin-only operations, so as you can see here. So we want certain users in our user pool to be able to do these and certain users not to be able to do these things. To make it real, what these are in a conference room app like SpaceFinder, anyone could book a room or delete their own booking, but creating a room itself or creating a building with rooms in them is something only an admin should be able to do, as well as deleting buildings and rooms. So that's what we're trying to accomplish. Now, I mentioned there are 3 types of authorization, so let's take a closer look at each. But one other thing you might want to note is even if you're not using a fully serverless stack today, you can put API Gateway in front of any existing application where you have an API and leverage this not just in a serverless environment and still offload your authorization challenges, logging, DDoS prevention, and other things. But the first one is Cognito user pool authorizers. So with this, if you have users that are using Cognito user pools, The way this works is you first have those users authenticate with user pools and get back a set of JWT tokens. And then you take the identity token and you send the identity token to API Gateway in the header of your choice with your request. So most likely the authorization header. API Gateway can then read the token, actually check its signature, and check if the token is still valid, since an identity token is only good for 1 hour. And if it is valid, then and only then would we go ahead and invoke the Lambda function behind API Gateway, which then would use its IAM execution role, so an IAM role specific to each Lambda function, that allows it to talk to other AWS resources. So in this case, Amazon DynamoDB. So that's a user pools authorizer. Key thing here, it's just going to check if a user is a valid user in your pool. It's not going to be able to differentiate our standard users and our admin users, though. So for that kind of fine-grained authorization, we have 2 other options. The first option is something called AWS IAM Based Authorization. So with IAM Based Authorization, you would first authenticate with Cognito user pools. You'd get back your JWT tokens. You then go ahead and you get an IAM role, as Vladimir showed you. So you request your creds. You get back, behind the scenes, the validation, Cognito takes care of all of that for you. And you get back your temporary AWS credentials. And then once you have those, you're able to send your request to API Gateway, signing it with a process called Signature V4, or SigV4, which is our signing algorithm. This is the same request signing process used for all AWS APIs. So whether you talk to S3 or something else. And API Gateway is able to extract from the signature which role signed this request, and for that role, check which policies the role is associated with. And then based on those policies, actually see if the user is allowed to invoke the operation requested, it would then go ahead and invoke Lambda just as before, which then uses its role to talk to DynamoDB. So I mentioned the policies. How might that look? Well, here's an example of a very simple IAM policy for your reference. So you can see in this policy, the key action here to note is something called execute API invoke. And in this policy, we're allowing our users to allow them to access any operation in the API with the exception of post operations on our locations path and subpaths. So this, and in real life, as a best practice, rather than doing this kind of blacklist approach of denying certain things, you'd want to whitelist only the things your users need as APIs dynamically change over time, and you might not update the policy. But denies always take precedence in IAM, so the user is effectively disallowed from certain things here. So the final option is something called a custom authorizer. So custom authorizers are implemented via Lambda functions, and here's how they work. First, you authenticate with your identity provider of choice. So that one difference here, you don't have to use Cognito at all to leverage this feature of API Gateway. As long as you have an identity provider that can provide a bearer token for you of whatever format, you can then take that token and get that back from the provider, then send that token to API Gateway in your request in the header of your choice. API Gateway checks its own local cache to see for that token if we have a known valid policy for the user, an effective policy defined via IAM for them. And if it doesn't know who they are, then it invokes the Lambda function, which is your custom authorizer Lambda function, which can run the business logic of your choice, talk to any third-party service or ID provider you may have to validate the user and determine what access they should have, ultimately sending back a well-formed IAM policy back to the user. So once this is back with API Gateway, we check the IAM policy that we got back to see if they have access for the operation they've requested. Assuming they do, invoke Lambda just as before, which then accesses Dynamo. Now the key thing to note here, upon the second request of the same user to our API, we would have that policy cached locally for that particular token, and we wouldn't need to invoke our Lambda function. We can immediately make a decision around if they have access or not. And you configure the validity and the timing of how long that cache is good for. By default, it's 5 minutes. So I know when I first heard this, I thought, well, custom authorizers, I need a Lambda function to generate an IAM policy that's well-formed. How would I go about that? We have a Lambda function blueprint out there today if you go to the Lambda console and search for authorizer, both Python and JavaScript, where you can see a sample of here. And all you have to do is say allow method, deny method, provide the operations you want to allow, deny the operations you don't want to allow, and then ultimately do a callback. So my first very simple custom authorizer, I was able to get working in under 10 minutes using the blueprints that we offer. So in summary, we have 3 types of authorization with API Gateway. User pool authorizers for users of user pools that need simple sort of valid user yes/no authorization. IAM based authorization for fine-grained access via IAM policies and Cognito federated identities. And then finally, custom authorizers, which are the most flexible in providing you with effectively any identity provider and being able to generate a policy on the fly for them, specific to that user. Of the 3, the most secure is IAM-based authorization. And the reason for that is because every request is uniquely signed. And with the others, if I were able to intercept a request, even though TLS is required with API Gateway, and if I were able to read the header and get that token, for the duration of the validity of that token, I could make impersonated requests to API Gateway and be able to do things. But with request signing via IAM, every request signature is unique, including the payload of the request, the operation of the request, the path of the request, etc. So even if someone got my signature, it would be invalid and useless to them upon their next call. So it is the most secure whenever possible. And to make that process easier, of even signing the request to API Gateway itself can generate SDKs in mobile and web languages that have the signing library already built in. So you don't have to go and implement all that signing code yourself. So to make this more concrete, let's show you how SpaceFinder uses these features. So first I'll show you SpaceFinder's API. So it's a simple RESTful API, all the paths here like you saw. And each given operation under a resource, you're able to define particular auth details for the request. So when I go to, say, the list locations method, aka show me all the buildings, this particular request, I'm requiring authorization. But I can pick by operation in the API what type of authorization I want to require. So this one's using a user pool authorizer. For demonstration purposes, SpaceFinder uses all 3, but in practice, you would want to just stick with one type of authorization for simplicity on your partner and customer side's integration with your API. So that's an example there. Another thing to look at here, we can define our authorizers. So we have our user pool authorizer, our custom authorizer defined. And we can actually take a token. So let me go pull a valid token. So this is Vladimir's account he just signed up with. And I can use the tester to show you passing in that token with the custom authorizer that request gave us something similar to the sample we saw. So we've allowed him access to anything with the exception of denying deleting and posting on the locations paths and subpaths, so deleting a room, creating a room, etc. So that's an example of custom authorizer. That logic just ran dynamically right then. So to show you it in the app, let's go over to the app again. And I'm signed in right now as a user. So if I go and for instance, if I try and call that same request, that list locations, without passing any auth header, you can see I immediately get a 401 response, an error response, which says you're unauthenticated. If I try the same request again, and this time, what we're doing here, we're showing you the details of the request just to make it more clear what's going on. But this time, I'm sending an authorization header, which is my identity token. Then you can see all of the buildings have loaded as we'd expect. So So I hear there's an event in ARIA today. So let's pull up this building. And you can see now we're actually using an IAM-based GET request for authorization. So with IAM authorization, unlike the first type of request, we're sending several headers here. So we have an authorization header itself, which has multiple parts. And then we're also sending an X-Amazon date header and an X-Amazon security token headers. These three together make up that signature I'm talking about with AWS Signature v4 signing. But it was a valid signature. We have authorization on this resource, hence our building's loaded. So let's go ahead now and say, Ironwood. This is another IAM request. It loads is fine. And now when I go to book the resource, we use IAM authorization here as well, but on this post, the thing to note, all of this payload information is also part of the signature. So if someone were to call the same endpoint again, same operation, tamper with the payload, the signature would be invalid. Now if I go to bookings, you can see I have my booking. But let's say, even though this is not an admin user, I'm going to turn on our admin UI to try and call some admin things. And so for instance, let's go in and try and add a location. And I'll say test location. Right, and I try and call this, and you can see, because I'm not an admin, my IAM policy did not allow me to actually do this post request, even though I am authenticated with IAM and authorized. But I got a 403 response, which means I know who you are, but you're not authorized to do what you're asking. So let's go ahead and sign out now and sign in as, say, an admin user. So if I sign in again, same exact process, but you can see our UI is dynamically reading our token to change our experience here. And you can look in the actual identity token. We've decoded it here for you. And you can see, because I'm in that admin group, that I get, my group is admin group, right? I'm in one group. And that admin group's role was this particular IAM role that allows access to anything on the API. And then if I had multiple roles that might apply to me, they're here. But that choose role from token option that we looked at, it's parsing this preferred role attribute, which is generated dynamically by Cognito. So now that we're authenticated properly, let's try this again. And this time it succeeded. And here we have our test location. And then just to show you an example on the custom authorizer, now we want to do a post on our resources underneath the location. So for instance, if I do this as an admin, it also works. So let's take this user and we'll see the difference. So if I take this identity token back to our tester, I run the test for our custom authorizer, you can see I also got a policy back, and this policy allows everything. There's no deny statement like our first user. That's why we were able to create that resource with a custom authorizer or with IAM. We've set it up for both. So that's just a look at the different options available with API Gateway Authorization. And now SpaceFinder, functionally wise, is complete. Right? We can sign in and sign up, can access AWS resources, and we have our own business logic necessary in our serverless API. But what if we want to allow users to federate their existing identity providers? We're hearing customers ask more and more about identity federation. So I'll turn it over to Vladimir to discuss how that can be implemented.
Well, previously, prior to earlier this year, if you were using Amazon Cognito and you wanted to federate third-party providers, what you would have to do is create the UI, create all those buttons, create all that UI logic, and possibly the backend logic. And you have to manage all of that functionality. Now, we have released a feature called Hosted UI. So what that is is it allows you, with a click of a button, to create a UI which is highly customizable. It allows for federation with Facebook, Google, and Amazon, and also with SAML 2 providers. And it supports all of them. So basically, it acts as your universal user directory. Not only that, what happens when you use the hosted UI, all those parameters and all those attributes that the third-party providers give you access to are copied over into the user pool. So now, in your application, you only need to talk to Cognito user pool rather than to any one of those providers that the user has logged in with. So the flow is quite simple, right? You have the hosted UI presented to the user. The user picks out what he wants to log in with. So in this case, Amazon. The user is redirected to Amazon's login landing page, enters his username and password. Amazon takes care of the actual login, and the user is redirected to Amazon Cognito user pools with all of those credentials that you saw previously, and with additional credentials from Amazon as well. So now, within your application, you have access to both. And you can, if you wanted to, you can talk to Amazon directly. With SAML and your enterprise IDPs, the process is quite similar. The user chooses which corporate IDP to log in with. User is redirected. The corporate provider takes care of the actual login, and you're redirected back to Amazon Cognito user pool. So in order to demonstrate this, Justin will take over.
Okay, so we just mentioned, the identity federation features. So let me go back to SpaceFinder yet again. And this time, let me sign out. And if you notice, we have an option at the top here. We've been using our own custom application UI with Cognito's SDKs so far. But there is another option available, the hosted UI that Vladimir mentioned. So when I click that, I'm on a mobile device, so it pops up a new tab for me. Now this UI, we've turned on a few options, but this is all out of the box. We haven't customized the styling in any way. We haven't uploaded a logo or done anything which is heavily customizable, as you'll see. But from here, we could sign in as our existing users, with a username and password, but we can also federate with any of those providers. And Cognito will take care of all of the behind-the-scenes magic to get everything in one place. So having an endpoint that you can receive the post on from a SAML response, and mapping attributes, et cetera. So let's take a look at that. So let me first sign in with Google. See here I come to Google. So let me actually have a new account here. Okay, and then now for my account, I just finished signing in. So my sign-in was successful, and if you notice, here comes the UI. See here? Let me actually just sign in one more time. So here comes our UI, and you can see I'm signed in. Now, because it's a mobile app, especially if you were doing a SAML response directly, SAML only supports a redirect response or a post back to your client. Well, on a mobile device, neither is an easy option. So Cognito actually intercepted that post response from the SAML provider and provides us a standardized set of these JWT tokens that are always the same regardless of where you came from. And then we get the callback actually from Cognito itself to actually do this sign-in. So if you notice the app went dark and popped up again, it's because on a mobile device, it used a deep linking callback. So SpaceFinder : / callback was the actual path. For a web app, we would just use a simple redirect callback. So just to show you, because we did instantiate a new version of the app with our callback, let's switch over to that. And you can see here, the process was the same. Even though we came in through Google, we got the same JWT tokens, the same access token. We have a different username here because we had a different ID. But if I go around in the app and do anything, it's all the same. So everything is identical here. Now let's sign out this time, and let's do a SAML provider. So in this case, we're showing Okta here. We've integrated Okta, which has a SAML endpoint as a sample. So let me sign in with Okta. But this could be any SAML 2.0 compliant provider. Oops, fix that. Okay. And you can see I'm successfully signed in with Okta. So here we go again. And you can see my username, because of how we're choosing to map it, is just my Okta unique identifier, which happens to be my email. So it's prefixed by the user pool. So let's look at this in the console. So if we go back to the Cognito console, we have two additional sections we haven't looked at so far, which is app integration and federation. And in our app integration, for this hosted UI, you can customize your desired domain prefix for your domain. And you're able to set per app client, so we have our admin client, here's our app client here, the callback URLs that you want to support. So here's our SpaceFinder callback you just saw. And the desired identity providers that you want to enable for each app client, as well as which flows you want to enable from an OAuth 2.0 perspective. So we support auth code and implicit grant, etc. Now we're using the auth code flow here. So we got an auth code back, then we did another request to Cognito, which gave us those final JWT tokens. With the implicit flow, we would just get the JWT token directly in the callback. And then, of course, you can define the different scopes. So how would you set up the different identity providers? Well, if we go here, it's as simple as saying for the social providers, say Facebook, registering an application on Facebook's developer portal, pasting in its ID and your secret, and the scopes you want to allow, and hitting enable. And that would enable that. Google is the same app ID and secret is all we've got there. For SAML providers, it's a bit different. So SAML providers, if we look here, to find Okta, you have a metadata document that you need to specify, which all SAML endpoints can provide. And you give it a name, and then you can indicate something called the identifier. And what the identifier does is if you have multiple SAML providers, you can give them a particular string to parse in a username. So most likely this would be a domain name, like Amazon.com or something else. And instead of having a button that said Okta, I would just say, sign in with your corporate email. And if I type in Justin at Amazon, it would read the Amazon.com part, and it would send me to my Amazon.com corporate sign-in page, hosted by our SAML service. So you can have many different SAML providers, all with one UI, and behind the scenes redirecting them. And then the other part, as Vladimir said, we have a universal user directory. So how can we get a consistent view of our users? So if we go in here to Google, Google provides all of these standard attributes for our users. So I've mapped them into user pool attributes. So most of these were just out-of-the-box user pool attributes, like email and name. But I've also set up a custom attribute for my access token from Google and when it expires. So if you want to capture your access token from these other providers to be able to make calls on their behalf directly with Google or something else, it's as simple as creating that attribute and then mapping this to it. With SAML providers, it's much the same. So here's Okta. SAML is SOAP-based, so it depends on the provider how this looks, but I just have my different attributes, and then I map them to the name. So when I look at my users that have actually been in the pool, you can see which ones have come in through standard username password signup versus my federated external users. But when I click into them, the attributes of Cognito are the same. So my given name is Justin, last name, email, all of that's been mapped into one consistent schema and universal user directory for all of my users. And then the final thing to know, as I mentioned, our UI, the hosted UI is very customizable. You can get an idea here of all the different types of things you can customize, from the styling of an error message, to the label, to the logo, legal text, and more. So one final thing we're hearing from customers is how can they migrate to use some of these features if they're already using user pools. So I'll turn to Vladimir to tell you about how that's possible.
There's actually a lot of ways of migrating. Now, I'll talk about two of the ways. So the first one is a bulk import. You export users from your current user directory. You create a CSV file from them. And then you run an import job and repeat. And then what's going to happen is you need to inform your users that they will have to reset that password. So let's assume you don't want to, you want a more seamless migration, and you don't want your users to reset, to have to reset their passwords. What do? Well, there's a one-at-a-time migration. What that is you will have to tweak your UI a little bit to first try and authenticate the user with the Cognito user pool. If the response that you get is the user does not exist, then you would authenticate the user with the current directory. And if the user exists and has successfully authenticated, in the background, you register the user with Cognito user pools. And basically, you will have to give it some time in order to allow your users to go through the flow. At the end of the day, some users will not use your application, for example. So you will still need to export those users and import them, and they will need to reset their passwords afterwards. So just to wrap up, we've created a mobile application that allows your users to sign in, to upload their profile images, and to search for conferences and to book them. But it doesn't have to be a mobile application. It can be a web application. And this application is actually written using JavaScript. So you can run it in your browser. And this is the GitHub repo. We have a bunch of Cognito reference architectures on AWS Labs, so please take a look at them. And if you're interested in this session, you might be interested in these related sessions as well. Please complete your evaluations, and thank you.
So for those interested, we'll hang around for questions, and then the Cognito team, if you guys could stand up. So they're back in that corner. Some of the Cognito engineers and folks are here. Feel free to ask any of us questions.